Good afternoon. We will be presenting on Fridge Ed, a retrofit to the modern commercial fridge smart management device. I'm Casey. I'm the project manager.
I'm Eureka. I'm the hardware lead.
I'm Rory Murtaugh. I'm the software lead.
So in September 2015, the first National Food Loss and Waste Goal was launched in the United States. This called for a 50% reduction by 2030. According to the United States Department of Agriculture, 30 to 40% of our national food supply is wasted. 31% of this food loss is at the retail and consumer levels. This is equivalent to 33 billion pounds of food. In 2010, this waste was worth $161 billion. In addition to $1 billion that are spent, tons of oil, water, and energy are lost globally every year, producing food that's never consumed. Food waste in the United States makes up the largest component of municipal solid waste. A big contributor to food waste in the United States takes place in the restaurant industry, where food is handled at very large quantities, and where food waste until recently has been seen as a low priority. The restaurant industry makes up the second largest private sector in the United States. This translates to a large scale of labor that uses a large scale of resources to make a large scale of products. 10% of the supply of food is wasted before even hitting the plate. Restaurants buy, store, and use large quantities of perishable food like produce, meat, and seafood, but it is very hard to efficiently manage, utilize, and restock that food supply in a non-tedious and non-repetitive manner. Food waste occurs at every stage of the food system, from the farm to the table. Our goal with Fridge Ed is to help eliminate the amount of food wasted in the restaurant because of spoilage. This is a result of poor inventory management. This effort to mitigate the amount of food wasted also allows companies to evaluate their food usage habits and make appropriate actions to cut spending on food items that are never needed. Fridge Ed is a retrofit to the existing commercial refrigerator walk-ins that are found in restaurants. Fridge Ed is a customizable smart management system that visually manages a large inventory of food. Fridge Ed is comprised of three main components. The first is the camera that recognizes the item that's going to be placed in the fridge. The second is the shelving attachment that the item is placed on. And the third is the restaurant's account webpage that displays the items that are in the fridge along with their location and the expiration information.
So as we were designing our system, we like to keep in mind that we wanted to create a unit that was easily maintainable and automated. Our goal being that a user would be able to manage food items going in and out of their fridge by simply placing an item in front of a camera. To do this, we broke down our hardware components into two main components. The first being the Raspberry Pi. The Raspberry Pi hosts our server as well as our database, and also runs our image recognition software. The image recognition software is able to identify different foods and insert them into the database. When an item is recognized, the item can be placed onto our forward load cell sensor system, where the data addict is initialized to our database. Our database was made using MySQL, and we utilized the Django web framework to create our database. The data from our database is analyzed with Python scripts and displayed on our front end. This way, our user has a centralized hub that they can monitor all items in their fridge, the quantity of those items, and the expiration date of those items based on FDA food and safety standards.
So our hardware components include the Arduino Mega, the Raspberry Pi, 4 load cells, the HX711 amplifier, and the breadboard. So here are some optimal performance factors that we included in our design.
So the first thing that we focused on is health, because we have to make sure that the weight is accurate. because then, and the picture also identifies the right food, because if it wrongly identifies the food, then the wrong expiration date would be inputted into the system, and then the food could result into going bad, and it could lead to food poisoning. And also that leads into safety, because we have to make sure that the load cells, since they're in the fridge, they have to be able to withstand the cold temperatures.
Another factor is taking into account the cost and environmental sustainability of the project, and as well as deriving the relationship between the input and output timing and the quality of the measurements. So here are the hardware, the full unit of the hardware section, which includes the HX711 amplifier, the Arduino, the Raspberry Pi, and the 4 load cells as our main components. The HX711 amplifier is a 24-bit ADC that is designed specifically for for the weight scale to be interfaced with the sensors. So that was gave us an advantage in this design, especially because there are internal registers that control the process of the amplifier, and we can manually work with this through the pins of the amplifier.
So the related theory related to our project is that with the image recognition, it uses convolution. So basically what happens is when it sees the image, it breaks the image down into smaller kernels, and then it runs through each kernel. And as it sees the image, identifies the image, it gives it a certain percentage as to what that image is similar to. So if this is showing that, like, if it was looking at an apple, this is what the image would identify, saying that's closest to an apple. And then also for our system with our sensors, they are arranged in a Wheatstone bridge. So the sensors act similarly to the variable resistors, where they are arranged so that the R1 over R2 is equivalent to R3 over R4, so that when they are balanced, the voltage output is 0. So then once a force is put on top, then it changes the resistance, which then changes the voltage, and the voltage is proportional to the weight of the object on top. And because of the way it's set up, the output is in millivolts, which is the reason why we use the amplifier, so that we could accurately understand what the weight is that is put on.
So for our software design, we focused mainly on the integration of our hardware components to the user display. To do this, we utilized our Raspberry Pi 3 Wi-Fi capabilities and hosted our server as well as our database on the Raspberry Pi. This way, any user that is connected to the same Wi-Fi network as the Raspberry Pi has the ability to access their data. When the data is input into the database, we performed Python scripts to analyze the items information and reorganize them on our web page based on expiration dates. So here we have 2 PHP scripts that are activated when an item is initialized on the weight sensors. When an item is placed on the weight sensor, it is first recognized by the image system, and then when it's placed on the weight sensor, the most recently scanned item is added to the database and then connected to our front end. So here's our database. The database is centralized around the fridge model. Initially, this model is not populated because it contains all the items that you would be adding to your fridge. The products model contains all of the information of different items that can go into your fridge. I populated this model using FDA codes and standards with different information about food items you may find in a restaurant. To the right, you see the models written in Python using the Django web framework. that it was able to transfer these models to a MySQL data code. So the Django Web Framework also allows an admin feature where any user is able to modify, delete, and change the tables manually. And to the right, you see our front-end display. There's 3 test items that were input to our system. They were input apple, banana, and then meat, and reorganized based on days till those items would expire.
So this is our unit testing framework, which takes into all the checkpoints of our hardware and software integration on the hardware section. So we first use the one load cell as a test to see if there would be accurate readings just with one load cell, and that ended up being not accurate, not giving us accurate results. So then we also saw the integration between the Raspberry Pi and Arduino, and that wasn't relevant in our project at the moment. And then it ended up being that the 4 load cell mechanism was the most suitable for our entire project.
Yeah, so for integration testing, we broke it down to a 3-step sequence. First, we manually added items to our database and processed the data to our front end. This was successful, and users were able to see all the items in their fridge and when they will expire. Next, we used Arduino to monitor a weight of the item and populate a text file with 40 pre-displayed item values, so that a PHP Python script reads from that text file and adds to the database, and that was successful. But we ran into trouble when we were trying to recognize an item using the image recognition software and connecting that to the Arduino. So we were only able to recognize a small range of items, and the items were sometimes misrepresented in our database.
So for our project, a way that we could have improved it if we had more time was because we added our Arduino later on, we ended up using a Mega. But with the Mega, it is a load regulator, so it runs constantly. So that means that the battery capacity, the battery would die out a lot quicker. So a way that we could fix this was be switching to one that is a switch regulator or using a boost converter. And another way that we could help this with the battery life is to use sleep interrupts, so that, because we don't always need to be measuring the weight on the scale, we only need to do it maybe 3 or 4 times a day.
Another improvement includes creating our own PCB so that we can have more control over the operation of it and to simplify the design. We also would like to incorporate LEDs as a user advantage to help with the design of notifying the user of different functions, and would help in just the overall project. And also, it was important to learn from our mistakes, and we learned a lot from reaching out to other professors and people that could help us with understanding just some knowledge, basic electrical knowledge. And yeah, even though, yeah. Here's our demonstration.
So first, the item was the camera is pointed at the item and placed on the weight sensor. Once it's done that, it is recognized and input to the database. Here you see the item being recognized with the image recognition software. Displays an apple. and here is the item being added into our content.
So the total cost breakdown ended up, we only used about $130, which is under budget. And we were able to use the school's Arduinos and Raspberry Pis, which allowed us to keep the budget so low.
We followed the EECE codes and standards for the sensors and the Wi-Fi to ensure accurate readings. And our system complies with the FDA's Food Safety Modernization Act, which and their efforts to improve protection for public health by strengthening food safety systems. This follows the aim to prevent food safety problems rather than relying on primarily reacting to them. And this was also our motivation to ensure that ensure accurate data collection and representation, because we knew that this representation would dictate how users interact with the food that they are purchasing. And then, again, our goal is to help combat the USDA statistic that 30 to 40% of food supplies wasted, while also providing economic interest for restaurants. And finally, our system and the efforts made to create it follow the EECE code methods. Any questions?
Yeah.
Is it supposed to be a refrigerator eventually?
It's supposed to be inside the refrigerator.
Conceptually, would it be that you put the product in the refrigerator?
Like in commercial fridges, it's like the walk-in. So it would be that they would have the shelving units, and then our device would just be placed on top of the shelving units.
This is commercial.
Yeah, this is commercial. No, not home.
Oh,
It's important to note actually that we started off not with the commercial design. It started off just in like a smaller scale for someone's residential fridge, but then we realized we looked at it from a new perspective, and we just made some additions such as the weight sensors instead of simple temperature sensors to expand the hardware in our project.